Hey students, this is the note section 10.4 on common tangents. So we learned what a tangent is. A tangent is a line that touches a circle at a point. So in my picture here, um, this orange line is tangent to the circle because it's touching at one point. Okay, so then we have 5 situations that are going to happen when we have our tangents. So you don't have to, I do want you to draw these, but you don't have to be as detailed as I am. Just make sure you've got them written down. Go ahead and pause the video and copy this down. And then I'm going to move it up. Pause the video and copy that down. And then pause the video and get that last one. Okay, so now if you have them copied down like you're supposed to, I can talk about it or you can listen to me as you copy it down. So we have what's called externally tangent and internally tangent. And this is not the main focus of the lesson. We're going to get to some theorems that are the main focus. But it's kind of, this is my favorite, like one of my favorite sections because it's so easy. External, outside. Internal, crosses through the inside of the circles. Okay, and it still has to touch both circles. So notice the yellow lines touch both circles, the orange lines touch both circles. Okay, so a picture like this where the circles are separated has 2 external tangents and 2 internal tangents. And we say common internal tangent, common external tangent. All right, when the circles are tangent themselves, we have still 2 external tangents, but we only have 1 internal tangent. When the circles are overlapping, we no longer have an internally tangent line, but we still have the externally tangent. When the circles end up having one circle in the other, the circles are still considered tangent because they're touching each other at this point. There is only one common tangent. This line can only touch those 2 circles at one point. So this is one common external tangent. And then when the circles are not intersecting at all, there's no way I could draw a line that will touch 1 or 2 or 3 or 2 or 3 of the circles. So there are 0 tangents. There are no other possibilities when you have 2 circles. Okay, let's get to the real part of it. So here's our first theorem. The theorem says if 2 segments are tangent, so I've got this segment here, tangent, it's touching right here at F, it's touching right here at G. If 2 circles are tangent, if 2 segments are tangent to a circle from the same external point, then the segments are congruent. This is so easy because they look congruent, they are congruent. Okay, so if it's tangent to the circle, it makes these 2 segments equal. I call this the ice cream theorem. So super easy. So then you have problems like this where you have the 2 pieces equal to each other. Solve for x. And square root, we are only getting positive values. I actually can have both answers because when I put in a -5, some of you have struggled with this. When you are substituting in a -5, it is in parentheses. So that is 25 plus 24 gives you 49. So be sure you are checking your positives and not just throwing out your negatives. You actually have to check them. Okay, so I want you to do problem number 2. You should have got y equals 8, putting the 2 parts equal, and then I wanted to show you that when I substitute in, I get 14 and 14, just verifying that this theorem works. All right, our next theorem. Put a box around this because it kind of just blends in. There we go. So this is our next theorem. We have kind of seen this in some of the problems already, but now it's official. It says if a line is tangent to a circle, so this line L is tangent to the circle, then it is perpendicular to the radius drawn to the point of tangency. This is a big deal. When you have a radius touching a tangent, it is making a right angle here. Well, guess what kind of triangle we're going to have? We're going to have right triangles. 30, 30, 60, 90, Pythagorean theorem, Pythagorean triples, all sorts of things are going to start popping up. So what you want to do in these problems is if you can draw a triangle, you want to draw that triangle. And remember that radius can be drawn in any direction. Okay, I love these problems. All right, for example, number 3. That's a 7, in case you were wondering. I put a little mark to show that it's a 7. So if this segment is 7, then because this is the radius as well, it is also 7. And look, we've got a 7 and a 24. So what would this be? It is one of our triples. So HF is 25. HF is 25. Very simple. Okay. Now, number 4. Okay, let's throw in some meat and bones into this algebra. So this is R. This is 8. What would this be represented by? R plus 4. So our right angle is here. Leg, hypotenuse. We're going to do the Pythagorean theorem. So R squared plus 8 squared equals R plus 4 squared. Remember, you are going to FOIL this. Now, let's just do a little bit of honors math. All right, R plus 4, R plus 4. R squared plus 4R plus 4R plus 16. Notice these are the same. R squared plus 8R plus 16. Okay, you guys need to get to where you're doing this. This is a binomial squared. Square the first. Take the sign that's in the problem. Double this. Multiply these together and double it because we have 2 of them. See right there? So you multiply these together, 4R, and then you double it. Don't square it, you double it. So that's where I get the 8R. Always have a positive here. Always end on a positive note. Square the last. All right, so hopefully if I see that again, I'll try to reinforce that with you. But you need to get to where you're looking at that and going straight to this. Okay, now the R squares are gone. I'm going to subtract 16. R, I believe that's 48, and R equals 6. Does that make sense that this piece should be equal to this piece? Does it also make sense that if this is 6 and this is 10, 6, 8, 10? That should make sense to you. Should be ringing a bell. Okay, flip over. Okay, let's look at this picture for this example on the next page. So before we start putting this information in here, question 1, 2, 3, and 4 can just be answered based on vocabulary. So I'll help you on number 1 and number 2. Circle W and circle Z, okay? So they are touching, and they are touching on the outside. So they are externally tangent circles. Okay. Circle Y and circle Z, these 2 circles here. The circle Y is on the inside of circle Z, so they are internally tangent circles. Okay. TX is right here. There was a picture on the front page, and there were some words that went with this. So I want you to tell me TX is a blank, blank, blank. Look on the first page, and I'll help you. The first word is, and the last word is. So TX, what word would you put there? All right, if you picked external, you are good. All right, number 4, I'm also going to ask you because these are easy questions to get right. H is a, okay, this line right here is a common blank tangent. What word would you use to fill in that blank? If you picked internal, you are on the ball. Way to go. Okay, so now we're going to answer some questions with some values, and we're going to put this information into the problem. So I am told that the diameter of circle Z is 12. So that means the diameter is not necessarily needed yet. We're not going to draw it in, but the diameter would be from here to here, okay, going through the center. It could be from here to here, going through the center. It, most importantly, can be from here to here, going through the center. Okay, so if this piece right here is 12, then what would this piece be? And what would this piece be? Because this piece becomes the diameter of circle Y, okay? And so you can get that information. So that is, we're not going to write this into the picture, but it's needed. We will put these in the pictures when we get to them. Okay, so what do you think the length of XY is going to be? Go ahead and give me that answer. All right, I use pencil because we've got a lot of problems, and I'm going to erase that when I don't need it anymore, but you should have put 3. So now you can answer number 9. What is this length here from Z to R? Well, because this is a radius and this is a radius, ZR is going to be 6. Okay, now let's do some calculations. All right, number 6 says YP. So YP is being drawn from here to here. And we know from our theorem that if this is drawn, it is a tangent. It's touching at a point of tangency. It makes a right triangle. So we knew that was 3. Okay. And it says XP is 4. So what would YP end up being? Okay. So YP, this is a 3, 4, 5. Please tell me you didn't have to do Pythagorean theorem for that. 3, 4, 5 triangle, so YP would be 5. Okay, and then the next question, we're going to erase. Okay, the next question is, what is ZT? So I grab this. Okay, so now we are using this right triangle, and we are told, let's see, is that what we were doing? I forgot what I was doing. We can use either one of those. So we're told that RT is 8. We are told that before, because the diameter is 12, that ZR is 6. So this is a 6, 8, 10 triangle, 6, 8, 10. So that means ZT is 10. All right, see what we're doing here? Let's get rid of all this. All right, now number 8, TX. So TX is this piece here, and you have the information from this theorem. What is the answer for TX? Look at the picture. I've got it right there in the picture. All right, it's that simple. TX is 8 because from here to here is going to be equal from here to here because these are tangents. And the theorem says that if 2 tangents are tangent to the same circle, then the segments are going to be equal. Okay, and then the measure of angle ZRT. So ZRT means if I draw this segment back in here, and we had it right here, that is a right angle, so that answer would be 90. All right, come down here to number 11. So look at the picture for number 11. We have concentric circles, and we have segment XY that we're trying to find. Now, they're going to do things like this where they have the pieces drawn where you don't need them. We're trying to always try to make a right triangle. So if I extend this piece down here, and then extend this piece here. Sorry, that wasn't very straight. All right, this is still the radius, this is 5. This is a tangent, so that means this is a right angle. And then this piece is a radius of the big circle, and so is this piece here. It's a radius of the big circle. So this big piece from here to here is 15, Pythagorean theorem. So 5 squared plus b squared equals 15 squared. I'm going to let you finish this problem, and I want you to be careful because the answer that you get is this piece right here, and I want the whole thing. So this is going to give you some practice with radicals. I want a radical simplified answer. Go for it. Did you get 20 radical 2 as your answer? That is the answer, 20 radical 2. All right, so when I worked out the Pythagorean theorem, I got b squared equals 200. That is 100 times 2. If you're still struggling with this, watch. You take the square root of the perfect square, that comes out. The number you cannot take the square root of stays in. So this piece right here is 10 square root of 2, and I need 2 of them to make up the whole thing. Everything is symmetrical in these circles, and so this piece here would be 20 square root of 2. All right, number 12, I'm also going to use pencil, 13 and 14, so we can use the same picture. We do have a tangent, meaning we do have a right angle here. So JO is 15, OT is 9. What is JT? Okay, so do we have another triple? We sure do. 3, 4, 5, multiply those by 3, multiply 4 by 3, multiply 5 by 3, 3, 4, 5. So JT is 12. All right, number 13. We are given that OJT is a 30-degree triangle, 30, 60, 90 coming up. JO is 20. And what is JT? Okay, that's what we're trying to find. Go ahead and try to find that answer, please. 30, 60, 90 triangle. All right, let's see if you understand what's going on. So I know this is 20, and so that ratio is 2x. 2x equals 20, so x is 10. That means this value is 10. This value is 10 radical 3. Hopefully you can do that now without writing the ratios on the sides, and you can envision this is your shorter side, this is your x, x radical 3, 2x. All right, great. And our last one, JK is 6, KO is 4, so that means this is going to be 4. JT is what? So this is 4, this is x, this is 10. We're going to do Pythagorean theorem. 4 squared plus b squared equals 10 squared. 1600. Was that 84? Whoops. 84, 90, yes, that's right. All right, I need a perfect square that goes into 84. Nope. Okay, so 4 and 21. So 84 is 4 and 21, so that would be 2 square root of 21. Okay, so back when we were doing sector and area and length of segment, decimal answers are good. But now that we're back to Pythagorean theorem, anytime you're doing Pythagorean theorem, I do want radical answers, not decimals. I will specify that on a test or a quiz just to make sure you've got it. That's it. Your work should be fairly easy because the concepts are super easy and there's only 2 theorems for you to remember. Lots of Pythagorean theorem happening in the next worksheet. Thanks, students.